In this video, we are going to be seeing some concepts regarding the unit impulse signals and impulse response. So we'll start off with the topic, and basically I would like to start mentioning about the unit impulse signal. So unit impulse signal, as you see over here, is a signal that arises at the position where n is equal to 0. So as the name suggests, it is unit impulse signal, and impulse basically refers to something happening instantaneously at this right particular moment. So that is why we take n is equal to 0, and when we call it unit impulse, we tend to refer the amplitude as 1. So which is why we have this statement over here, del of n is equal to 1 where n is equal to 0, which means a unit impulse signal can be represented by this graph. At position 0, you have this amplitude of 1 over here, an impulse signal, and it doesn't have anything that comes after it, it doesn't have anything coming before it. It happens at that very instant, which is why it is called as unit impulse signal and happening at this particular moment n equal to 0. The next concept that we are going to look into is a shifted unit impulse signal. Now, this unit impulse signal can be shifted. Basically, if you look over here in this graph, we already know about how the shifting of a signal happens. We have been looking at that in the convolution topic. So, a shifted unit impulse signal can be in two forms. One is del of n minus 1. And another, it can be del of n plus 1. Again, it is unit impulse, so the amplitude is 1. The concern is about the shift, and primarily the shift here is represented by n minus 1 and n plus 1 over here. So n minus 1, a shift of n minus 1 will indicate n is equal to 1. When n minus 1 is equated to 0, we can realize that n is 1. So that means it is shifted or existing at this position 1. Meanwhile, del of n plus 1 equal to 1, it will happen where n is equal to minus 1. So at this minus 1, you have this unit impulse signal, that is at this point. So generally, a shifted signal can be represented as del of n plus or minus k. Depending on plus or minus sign, it will depend on or it will just shift to left or right, as explained in the concept here. The next topic that I'm going to cover right now is representation of a discrete time signal as sum of impulses. So now let me make it clear. What does a shifted impulse mean? A shifted impulse basically means that it had happened at that particular instant and it moved front or it moved backwards. So it is like, when I say I am Anu Abraham Matthew, I happens at one instant, am happens at another instant, and Anu Abraham Matthew happen at three different instances. So if you look at the right, at the instance what I have said Matthew, the words I am Anu Abraham, these four words are shifted to the past. So if you look over here, it's like something that you have learned in your digital. Maybe in the case of registers, shift registers. If you have a binary value 1100, one gets entered into this particular register, then it gets to another, then it gets to another, then it gets to another, and at the output point you get 1 as the output. So I hope you remember concepts of like that. And basically what I wanted to say that a unit impulse will be happening at this instant, and the ones that come before it will be shifted as an earlier or prior impulses. So if I look at this particular diagram, you can see that the topic is basically representation of a discrete time signal as sum of impulses. Now, if you look over here, I have a signal here, a discrete time signal. X of n is 1, 2, 3, 4, and 5. Now, with the arrow under 3, it suggests that 3 is at the position 0. So, I have drawn my discrete time signal x of n over here, where this is 1, this is 2, this is 3, this is 4, and this is 5. So, it is clear from the equation given and the diagram that this corresponds to 0, so this will be -1 and this will be -2, and this will be 1 and 2. So I have represented it respectively. So if I want to represent it as sum of unit impulses, what I would basically do is I treat this as separate impulses. Now, since they are at different positions of n, they are independent. So that can be made clear, or it can be understood that these are existing at different positions, which means they are independent from one another. It is not depending in the perspective of time. So we can treat these as separate impulses. So what about this one? This one is, if it is treated as a unit impulse, what I could say is that this is shifted 2 places to the right. If you look over here, and del of n will be here, del of n plus 1 will be here, and del of n plus 2 will be here. So this impulse can be treated as 1 dot del of n plus 2. Why do I write it as 1 dot del n plus 2 can be understood maybe from this particular equation. Now, if I look at this particular sample, this is of amplitude 2. Now, we know that the amplitude of unit impulse signal is 1 and it is scaled up by a factor 2, which is why you have an amplitude of 2 over here, and it is basically a unit impulse signal. So I hope that point is clear. It is basically a unit impulse signal which is scaled in amplitude by a factor of 2. Again, when you look over here, this impulse, it can be seen as 3 dot del of n. It can be written as 3 dot del of n, because del of n will be equal to 1. It will be having the amplitude 1 and it is scaled up by a factor 3. And similarly, you have this sample and this sample. So what I have done here is I have split up this graph into these 5 components, and I have identified what are each of these components. So this will be 1 dot del of n plus 2. This will be 2 dot del of n plus 1. This will be 3 dot del of n. This will be 4 dot del of n minus 1, and this will be 5 dot del of n minus 2. So since they are independent from one another, we can understand that when we combine all of these signals or impulses together, we get this particular thing, since they are independent from one another. So that is why we can write this as x of n is equal to 1 dot del of n plus 2 plus 2 dot del of n plus 1 plus 3 dot del of n plus 4 dot del of n minus 1 plus 5 dot del of n minus 2. Now, that is the concept, representation of a discrete time signal as sum of impulses. Now, if you want to, now for some questions, you could expect to get signals in this particular format, and it should give you an understanding about what each of these components are. For example, if I give you a signal like x of n is del of n plus 2 plus 3 del of n minus 1. What will this mean? This will mean that x of n is essentially 1, 0, 0, 3. How did I come about with this? With arrow under this. How did I come about with this? It must be clear that del of n plus 2 will indicate n is equal to minus 2, and at minus 2 you have a sample of del which is of amplitude 1. So that means the next sample that you have here is 3 into del of n minus 1, where n is equal to 1 and its amplitude is 3. So in between you have 2 positions, minus 1 and 0. So that is why I have inserted the 0 samples here. So essentially this equation would convey that it is of this particular sample sequence. You could get a question of that sort, and hence you're supposed to prepare it in that way. Now we are going into the next concept of impulse response of a system. We did questions on convolution, and we saw that we often wrote the equation as x of n convolution h of n gives y of n, and you know that x of n is the input signal and y of n is the output signal. And what is h of n? probably this topic will give an idea of what h of n is. So right now we just spoke that a discrete signal can be represented in the form of impulses, and if we are considering a system x of n, system diagram over here, where x of n is the input signal, it goes into a system and you get a corresponding output y of n. Now this could be a filter, this could be an amplifier, it could be any kind of a system. Now what property of the system determines the output y of n? That will be given by the system property called h of n, or this is known as impulse response. So what is impulse response then? To understand that, I just mentioned in the previous section that a discrete time signal can be represented as sum of impulses. So x of n, the input signal, is also a discrete time signal, and hence it can be represented as a set of impulses in the form of sum. My point is, it can be represented as a set of impulses. So it is up to the property of the system on how to react to this impulses, which is entering into the system as the input signal. So if del of n is passed to the signal and it gives you an output h of n, then this h of n is called the impulse response of the system. Or in total, how the system works on an impulse is known as the impulse response, and it defines the system. So any system that processes the x of n to obtain y of n, it is guided by its impulse response property defined by h of n. So which is why we say x of n convolution h of n gives y of n, and also x of n, if it varies with the h of n that is given over here, it will produce different y of n. So it is a system property that defines the nature of the system and what kind of output should be obtained for that particular signal depending upon the system property. So we just looked into the concepts of unit impulse signal. Then we looked into discrete time signal as sum of impulses, and then we looked into impulse response of a system.